In this video, we're going to look at this problem on page 6 of the 2-1 slides. This is the McDonald's lunch service times example, which involves creating a frequency distribution of the data shown here. This data is a sample of drive-through service times for McDonald's lunches. And using this data, we're going to follow the procedure from the previous two slides, slides 4 and 5, to construct the frequency distribution of the data. We will use 5 classes. Now, as we know, the first thing we need to do is to, and I don't like the way this is probably showing up, so I'm just going to do that. That should be good. Okay, so the first thing we need to do is to find the class width. And we know that the class width is approximately the maximum minus the minimum divided by number of classes. Well, in order to do that, we need to know what the maximum and minimum are. Generally in this course, you're kind of expected to do this by hand, to sort everything out in terms of how much, what the maximums and minimums are, what goes into each class, and so on. I did this the easy way, so we'll look at that. And for that, we will go over here. And all I've done here is I took the data from the slide and I put it into Excel and just sorted through that. So we can see very easily, I just had it sort by the numeric order. So we can see very easily that the minimum here is 83. And going all the way to the bottom, the maximum is 308. So we come back here and we plug in those values. So we're looking for something that is approximately 308 minus 83 divided by, we were told to use 5 classes. Well, this is equal to 225 over 5, or 45. Now, we don't need to use exactly 45. As the slides say, we should use an approximate value. That's a nice round number. And the best round number that we're going to find that's close to 45 is 50. Next, we need to find the class limits. We're going to start with the lower class limits, and the lower class limit should be 83, or a number that is close to 83, less than 83, but nicer. And I am going to use 75 for my lowest class limit. So I've got 75. I'll figure out what my upper class limits will be later. But I know my width. And so I'm just going to add the class width to each of these limits to find the next class limit. So for the second class, 75 plus 50 is 125. 125 plus 50 is 175. 225, 275. And then I want to make sure that I have a place to put any data point that shows up. Well, we're using discrete data points that are all rounded to the nearest second. So the closest whole number I can get to 125 without actually being 125 is 124. So that's going to be my upper class limit, and I would just add 50 to each of my upper class limits. 174, 224, 274, 324. There we go. We've got our class limits now. Now, the next step is going to be to, I'm going to share this again. We'll go back to Excel. The next step is going to be to find everything that goes into each of these classes. Now, we could go and create a tally mark. In fact, I'm going to go over to the slides and we can tally for a moment just to see what that would look like. Let's do it this way. Okay, so we will go over to our slides right here, and I see, okay, the first number we would get is 107. So I go back to my to my paper and I make a tally mark for 107 in 75 to 124. And then we come back here and we've got a 130. Well, that's between 125 and 174. And then I've got 107 again. That goes in here, and so on and so forth. And it takes forever. I'm going to do this the easy way because I don't want you guys to, I figure you guys can tally by hand if you need to. But by sorting out all of this data in Excel, I've got all the values I need, and I can see very quickly that the largest value that is below 125 is this 123. So these 12 elements represent the frequency for our first class. We look here, and there I put the 12 under the frequency. And this may be reversed for you, so I'm going to stop looking at this, and I'm just going to fill in those values. When we figure that out, we'll keep going. So the next thing I want to look for is the first value, the last value that is less than 175, and that is 171, which is the 35th element in this set. Okay, well, we can take away the first 12 we had, which leaves us 23 for the frequency of our second class. And we keep going down. We look for the next value, which will be the first one that is less than 200. Sorry, the last one that is less than 225, which is 209, number 44 here. Okay, well, 44 minus 35 is 9. Let's keep scrolling down. Okay, then I look for the last one that is less than 274. That's 263. We can see that there are 4 elements that fall into the 225 to 274 category. And these last two are between 275 and 324, so they will go in there. Having done that, we can look at our final frequency table. In 75 to 124 class, we've got 12. 125 to 174, we have a frequency of 23. 175 to 224, we have a frequency of 9. 225 to 274, there's a frequency of 4, and 275 to 324, there's a frequency of 2. The one thing I will note here is that the slides have slightly different values than I do, and that is because I typed in the data set a little bit wrong. I'm not certain exactly where I went wrong, but it doesn't really matter for creating our frequency distribution. But that's it for this set of slides. If you have any questions, please get in touch.